frustrating thing in the sense that it's always there. It's not something that you can or can't choose to use. It's a part of JavaScript, and so it's very fundamental that you actually understand, kind of at least maybe not in the most precise details, but you have a pretty good sense of what it does. And essentially, what scope is it's a concept that refers to essentially which variables can be accessed at which location in your code. That sounds like a little bit confusing. So the best analogy I've heard for scope is imagine it as like a sandbox. It effectively what scope does is it defines the limitations or the area around which your variables are created and where they are able to be used. And more specifically, the idea is that when you create a variable in a given sandbox, it can only be used in that sandbox. And so with scope, the idea is that whenever we create a variable in a given scope, it can only be used in that scope. Right. So here on line 4, I've created a variable called wow, and I set it equal to the string wow. On line 5, I console log out wow, and I get wow. There's no surprise here, right? This looks like the JavaScript that we've seen so far. But what it's actually doing that's maybe a little bit deceptive, or at least not immediately clear, is that on line 4, when we actually create the variable wow, we not only create a variable wow, we are also defining where that variable is able to be used. In this case, because we are creating it kind of on the page as a whole without any boundaries, what we've effectively done is created something called a global variable. That is a variable that can be used across the global scope. And what is a global scope? As the name indicates, global scope just means everywhere on the page. And so far, most of the variables we've created are global variables, as in they're a variable that we create and we can access from anywhere else in our code. But today we'll see a few examples of instances in which that's actually not the case, and that we've created variables that can only be used in certain locations within our code. So before we keep talking about the global scope, let's kind of understand really quickly how JavaScript sees the entire page. Whenever JavaScript reads your piece of code or a page of code, it actually follows a very distinct process. Remember, once again, in computers, there's no vagueness, there's no ambiguities. Computers are very, very precise in how they read the code, how they execute it. And so whenever JavaScript sees a piece of code or sees a page of code, it actually goes through it twice. The first time it goes through it, all it really does is figures out what variables are on the page. Okay, and then the next time it goes through it, it then actually executes the directions of the codes are indicating. Okay, so I'll say it one more time. The first time JavaScript goes through the page of code, all it does is it goes through the page and makes a mental note of this is a variable, this is a variable, this is a variable. The next time it goes through the code, it says, oh great, I want to assign this variable the value of 6, or I want to run this function. Okay, and that's a very important concept for us to understand, because here on this page on line 5 there, I've effectively created, or rather I'm creating a console log statement that's printing out the value of this variable called wait for it. But obviously the problem is that as of line 5, I haven't yet defined a variable called wait for it. And in fact, I actually define it on line 7. And then on line 9, I print out or I console log out that variable again. When I look at the results, you'll notice something very interesting. On line 5, the first time I'm console logging out wait for it, I get back an undefined value. On line 7, I actually create the variable here I am, and on line 9, when I console log the same exact variable that I console logged out on line 5, I get the string here I am. And so this refers to a concept called hoisting, right? This idea that the JavaScript makes 2 passes on the code. The first time JavaScript goes through this code, it looks at line 5 and says nothing is being created, right? Let me skip to line 7. On line 7 it says, oh great, we've created a variable called wait for it, but I'm not going to give it a value just yet. I'm just mentally noting that this variable exists. And on line 9 it says, I'm not creating any variables, so I'm gonna skip it. That's the first pass that JavaScript makes on the code. The second time JavaScript passes through the code, it then goes to line 5 and says, let me print out the variable wait for it. Well, is wait for it a real variable? Yes. What's the value of wait for it? I don't know just yet. I've only made a note that wait for it is a variable. I haven't actually ran the code that assigns a value to it. And so when I make note of a variable that exists, but I haven't yet given a value, then the value of that variable is going to be undefined. We get to line 7, and that's where we actually assign the value here I am to the variable wait for it. And then on line 9, when I console log out wait for it again, now I'm actually console logging out the variable with the value assigned, which is here I am. Okay, so that's the idea of hoisting. And once again, the idea here is that on line 7, I've created a variable on the page, and we'll see the opposite of this in a little bit. But the idea is that because I've created a variable called wait for it on the page without any boundaries, that means I can use this variable anywhere else on the page. Okay. So if a global scope or a global variable is a variable that has no limits, one that we can use anywhere else on the page, then the next thing we'll talk about is a scope that actually has a limit. So in this case, we can think of something called a function, and there's something called a functional scope. So what is a scope that's not global? Well, we call it locally scoped, and effectively the rules around locally scoped variables are that variables that we create inside of a function can only be used inside that function. We cannot use it outside of that function. So here on line 5, I have a function called happy function. On line 6, I create a variable called message. On line 7, I console log out message. On line 10, I execute happy function. And on line 11, I console log out message. Now, when I do this, the first time that I'm running through this code, I go through lines 5 through 8. I see, okay, great, happy function is a function that exists. On line 10, I execute happy function, which takes me to line 6. I create a variable called message. On line 7, I console log out message. And if you look on the top right-hand corner of my screen, on the first console log, I print out, I am so happy. Now, when I get to line 11 and I try to console log out message again, I get an error, right? We see the text in the red that's printing out. And not only do I get an error, I get a reference error, which says that message is not defined. So remember what we talked about earlier. What does reference error mean? Reference error basically means that reference error basically just means that the message is a variable that doesn't exist. But we're saying, hey, look, I created it inside the happy function. Of course it exists. But therein lies kind of the power of scope, or the limitations of scope, right? Because we created a variable message inside happy function, we can only use message inside of happy function. It's almost like once we leave happy function, whatever is inside happy function becomes a black box. And so on line 11, when we try to use the variable happy message, well, from that position, we actually cannot look inside happy function. And therefore, as far as line 11 is concerned, the variable message does not exist because it was created in a function, and the console log on line 11 is not within that function. Does that make sense to folks? Very cool. So then what happens in the case of a collision? That is, what if a variable is defined both locally and globally? Well, on line 3, we have a variable called message, and we call it think globally. On line 5, we have a function called log message. And on line 6, we define another variable called message, and we set it as a string act locally. On line 9, when I console log out message, what happens? Well, this points to another key concept of scope, which is that whenever JavaScript tries to use a variable, it will always look for the variable within its own scope first. Okay, and so if you put yourself in the shoes of the computer, every time you're using or executing on a variable, ask yourself, does this variable exist in my own scope first? If it exists in my own scope, then I'm going to use that version. If it doesn't exist, then I'll look outwards. And the looking outwards is actually another pretty powerful concept too, and we'll cover that in the next slide. But for now, the message on this slide is just that we will look in our own scope, or rather we will look in the local scope first for the variable message. And on line 9, when we console log out message, we see that the local version of message is the one that's created on line 6, which says act locally. Okay. Now, what if we have an instance in which same exact thing as before, except now on line 6, I spell my message function MSG. And so on line 10, when I try to console log out message, what happens? And so here we come to another core idea of scope. Another core concept to scope, which is the idea that the variable message, or when JavaScript looks for a variable, it will always look in its own local scope first. Only and only if it can't find it, then it will look outside of its scope. but it doesn't look all the way to immediately the entire outside. It looks to see, am I inside another function scope, right? It's almost like those little like Russian dolls. Like you don't just jump out to the global scope right away. You always look more and more outwards. Analogy I sometimes give here is that if I run out of money, let's say my function in the bank account, if I run out of money, I wouldn't just ask my aunts or my great grandparents right away, right? I will look outwards, right, to my next closest local scope, which could be my parents. And if they don't have money, then maybe I can borrow money from my grandparents. But there's like a step, there's a sequence, right? And JavaScript operates the same way. Here on line 10, I'm trying to console log out the variable message. I look at my local scope in the function log a message between lines 5 through 11, and I don't see a variable called message. So then I look outwards. Now, what's outside of this log a message function? Well, the answer is outside of this log a message function is the quote unquote global scope, right? It's the end of the page. There's no boundaries. And so in that case, because I looked at my own scope first, I didn't find it, and I look at my next outermost layer, which happens to be the global scope, well, then I'll use the value of message that's there. And so now when I execute log a message, the value of the message I console log out on line 10 is the message variable that I created on line 3. And so this is something that is actually it's very intuitive once you understand the core basis of it, which is that whenever JavaScript looks for a variable, it always has to find it somewhere. Okay, it'll look in its local scope first. If it doesn't find it, then it'll look in its what we call the parent scope, so the next outermost layer of the scope. If it's not in there, then it'll look in its next outermost layer of the scope, and so on and so forth, all the way until it gets to the global scope. And if by the time I get to the global scope, I'm in my most kind of 30,000 feet perspective, I look for a variable and I can't find it, at that point, then JavaScript says, hey, you have a reference error. You're trying to use a variable that doesn't exist because I've looked everywhere for it and I can't find it. Another thing to just kind of keep in mind that be aware of that may be a little bit tricky is that parameters are also variables inside a scope, right? And so here on line 5, inside the log a message function, notice how log a message takes in a parameter called message. On line 6, I'm console logging out message. And so when I execute that function, I go to line 6, I console log out message. And the first question I have to ask is there a variable called message in my local scope, in my log a message function scope? And the answer is yes, there is. That variable was created on line 5, which basically says that the variable message is whatever parameter I fed in. Well, on line 9, I'm feeding in act locally as the parameter when I invoke log a message, and therefore that's what the value of message is on line 6. So when I console log it out, I get back the value of message act locally. Okay, so don't be tricked. Parameters are also variables, and they're locally scoped to the functions that they were created in. Any questions on that? Everyone good? Cool. All right. So here, if we take a look at something a little bit more complicated, let's look at a nested function. On line 2, we create a variable called global var, and we set it equal to the string global. On line 4, I have a function called outer. Inside this outer function, I create another variable called outer var, and I set it equal to the string outer. Inside this outer function, I have a function called inner, and inside of that, I create a variable called inner var, set it equal to the string inner. Okay. So far, all I've done is created 3 variables: global var, outer var, inner var. On line 9, when I try to console log out global var, outer var, and inner var, what happens? Well, when I console log it out, then on line 9, when I look for global var, I look in my local scope first, right? I look in the scope of the inner function first, which is between lines 7 and 10. I look for it, I don't find it. So then I go out to my next parent scope. My next parent scope with the function outer, right? Everyone see that? Like the inner function is inside the outer function, and therefore the outer function scope becomes a parent scope for the inner function. So then I look between lines 4 through 12 for the variable global var. I don't find it. Then I look outwards one more layer, which effectively is the global scope, and I look for the variable called global var. Do I find it? I do there on line 2, and it's equal to the string global. Great, I've now console logged out the first thing. For the second thing, the value is outer var. I look for it inside the scope of my inner function. I don't find it. I look out one more layer. I look in the scope of my outer function. I look for a variable called outer var, and I find it there on line 5. Great, I found it, and now I'll use that. And then last but not least, I would look for the value of inner var. I look at my own local scope. I find it there on line 8. And so when I console log out everything out, I get back global, outer, and inner. Okay, this is just the idea that this slide just basically highlights the concept of if you were JavaScript, how do you, or what order do you search for the variables in, right? So we always start with our local scope first, and we gradually work our way more and more outwards until we reach the global scope. So here on line 2, we create a variable called collision, so equal to global. On line 4, we have a function called outer that takes in a parameter called collision. On line 6, we have an inner variable, and inside of it, we create another variable called collision, we set equal to inner. Well, when I execute the inner function there, on line 8, when I console log out collision, what gets printed out? And so the first question is obviously pretty easy, right? What gets printed out? Well, whenever I'm trying to console log out a variable, JavaScript's going to look at my local scope first for the variable collision. Do I find it between lines 6 through 9? Absolutely, I do, right there on line 7. So then I print out inner. Okay? Everyone good here? Catherine, Irina? You guys good? Cool. Okay, so, yep, great. So here the solution is pretty easy, right? The variable collision I'm using is the one on line 7 because that's in the local scope of where the console log is on line 8. But what if I took that out? Okay, now what if I just had this? Same exact thing as before, except now I've gotten rid of the old line 7. So I'm now no longer defining collision inside the inner function, but I'm still console logging out collision. Where do I look for the value collision? Well, it's not in my inner function scope between lines 6 through 8. So let me look between lines 4 through 10. Is it a parameter in my outer function? And the answer is, yeah, it actually is, right? I see on line 4 there that the value of the variable collision is whatever I pass into my outer function. When I look at line 12, I pass in the string outer into my outer function. Therefore, when I console log out collision, it's equal to the value of the string outer. Okay, so what if I got rid of that parameter too? What if I just have this now? Well, now when I try to console log out collision, we look at my inner function scope first too. I don't find anything. We look at my outer function scope, doesn't find anything. We then go up to a global scope and we find the variable called collision on line 2 there. So that's the one that we end up printing out. Okay. Now, one of the things that we really highlighted is the fact that we can look in our parent scope, right? We can look in our parent's function scopes for variables. The opposite does not apply, as in we cannot look inside functions that we are not a part of for their variables. So here we have an outer function. On line 4, we create a variable called outer var. On line 6, in our inner function, we create a variable called inner var on line 7. And then on line 8, we console log out outer var and inner var. That works perfectly fine. The value of outer var is outer. The value of inner var is inner. But on line 11, when I try to console log out the value of inner var, which is inside the inner function, when I print out, so on line 8, the outer and inner prints out perfectly fine, right? But when I get to line 11, I try to print out the value of inner var, I get, once again, our old friend, the reference error. Why is that? That's an error because if I put myself in the position of line 11, I can look inside my own scope, but I can't look inside the scope of other functions. Okay? And so therefore, from the position of line 11, everything that happens inside the inner function is a black box. And so from line 11's perspective, I don't see line 7 and line 8, and therefore I can't access, or I don't even know that the variable inner var was created. And therefore, when I try to use inner var on line 11, I look in my local scope first, which is lines 3 through 12, excluding lines 6 through 8, or like 6 through 9. It's not there. I look on the global scope for a variable called inner var. I don't find it, and therefore I give back the reference error. Okay, so we can always look outwards for other variables. I think I can look at my scope, my parent scope, always do a global scope. But if I'm on the outside scope, I can't look inside another function scope for a variable. Okay. So on the other hand, if I run this now, this works perfectly fine, right? The only difference here is this looks exactly like the page from before on line 9 when I try to console log out outer var, inner var. The only difference is now I don't have to get my outer var from line 5, right? Why? Because does everyone see on line 7 there? Now I've basically added a parameter called outer var into my inner function, and so whatever the value of outer var, or the value of outer var is going to be whatever I invoke the inner function with. On line 11, I invoke the inner function with nothing. Therefore, the value of the outer var is going to be undefined when I get to line 9. So when I console log out outer var, inner var, I get back undefined comma inner, or undefined inner. Okay, and so once again, this is a very kind of logical sequence. There's no randomness, there's no kind of like, oh, like vagueness, right? It's very clear the exact order in which JavaScript is going to go through and look for the variables, look for the values of my variables. And so that kind of scope is set by the curly braces of a function. The other kind of scope that we'll talk about is something called block scope too, right? Block scope is also set by curly braces, except this time the curly braces are set by things that we've seen that are a little bit more common, right? Things like if statements or for loops or while loops. So here on line 4, notice how on line 5 I create a variable called block, and on line 6 I console log out the variable block. On line 9 I also try to console log out the variable block. On line 6 I get back the actual statement. On line 9 I get a reference error, right? Why? Because from line 9's perspective, I can't look inside other scopes, right? And that includes block scopes. So from line 9's perspective, I can't look inside lines 4 through 7, and I don't see a variable called block being created anywhere else. Therefore, I'm going to whenever you try to use block, I'm going to give you an error saying block does not exist or is not defined. Everyone still with me? Cool. Ah, you guys are good. And so one of the common questions we always get is, well, what's the difference between var and let? The idea behind var is just that var ignores block scope. So even if I do what I did before and I try to console log out block from outside of the curly braces, that still works. However, don't let this slide confuse you. At this point, at this like day and age, people pretty much only use let. Okay, so you can treat block scopes the same exact way that you treat function scopes when it comes to variable definition and usage. This is the difference between the two, but like I said, nowadays people pretty much only use let. So block scope as well as function scope applies everywhere. The last thing I'll talk about is we go back to what we started with, which is this idea of hoisting, except now we'll apply to functions. On line 4, I invoke this function called will this work. On line 6, I actually define this function, will this work, which console logs out yes. When I run this code, on the surface, it feels like, well, I'm actually getting an error, right? Because on line 4, I'm invoking a variable or I'm invoking a function I haven't defined yet. But remember we talked about hoisting, right? Hoisting, JavaScript does 2 passes on the page. On the first pass, it makes a list of all the variables. Another thing that it also does during that first pass is it actually makes a note of all the functions that we've created using function declaration. Function declaration basically means it's a way of making a function with the function keyword leading it, like we do on lines 6 through 8 here. And so on this page of code, what actually happens in the first pass is not only is JavaScript making a note of all the variables on the page, on the first pass it also notes, hey, will this work as a function? And it does, whatever we see between lines 6 through 8. On the second pass, then, when it executes line 4, it will actually execute will this work function properly, because the first pass would have stored the variable on or JavaScript would recognize and store the function, and on the second pass it will actually run the function. So the sequence in which that happens actually is perfectly valid, even though on this page when we see it initially, it looks like the function is not being defined until after we run it, but in reality it's actually being defined before we run it. Yeah, and so why it's called hoisting is just because hoist means to lift up, and what the concept of hoisting does is it lifts up all the variables and function declarations to the top of the page or the top of the scope. Yeah. Okay. The other way to define a function is something like this on line 6, right? We create a variable. In this case, we create a variable called will this work. We set it equal to the function. In this case, on the first pass, what JavaScript does is it does not store the function. It just acknowledges that will this work is a variable. It only assigns the value of this variable on the second pass. And so when I try to do this, I get an error. But once again, look at the error. The error is a type error. It's not a reference error. And the type error says will this work is not a function. Why? On the first pass, when JavaScript goes through this code, it hoists up the will this work variable to the top of the page. But what's the value of this will this work variable? Well, in the first pass, the value is just undefined. And so because of that, on line 4, on the second pass, we try to invoke the function. I'm actually invoking it undefined. and undefined cannot be invoked because it's not a function. And indeed, that's the error that we end up seeing. Okay, so hoisting works for us for the most part, and I would say that for the purpose of our curriculum, you should pretty much always use function declaration, aka whatever, or like defining a function like this, leading with a function keyword, as opposed to defining it like this, which is creating a variable first and then storing the value in it. And so lastly, some scope best practices. Functions generally should not change globally scoped variables, okay? And what that means is you don't, and in general as a best practice, you don't want to use global variables too much. Why? It's almost like saying I have a password to my computer that everyone knows, right? Well, if everyone knows it, then anyone else can use it, and more importantly, anyone else can change it, right? And so you don't want a variable that's easily changeable, because when you use it, you kind of want to have a good idea what the value is. And if someone else in the middle of it kind of takes it, changes it, does something with it, and you're using it without knowing that it changed, well, that's very dangerous for you, right? And so here on line 2, we have a global variable called always true that's equal to true. But on line 4, we have a function called don't mind me that takes that global variable and changes it to false, right? Because we run the function on line 8. And then on line 10, we check if always true, we'll do this. Otherwise, we're going to throw an error. And when we do this, we're going to get an error. Why? Because always true is now no longer true, because in an intermediary function on line 4 through 6 there, that changed our global variable to false. So when we use the always true variable, we don't actually know what we're using. One easy way around this is that if I also want to use the always true variable inside don't mind me, let me just create my own variable, right? Remember, or if I create my own variable called always true inside don't mind me, that means when I'm inside don't mind me, whenever I try to use a variable called always true, I will always look in my own scope first. Okay. So minimizing global variables is great because once again, you want variables to live only where they are exactly needed. You don't want to clutter the namespace with a lot of variables. So imagine if a lot of variables like let x equals 6, let x equals this. Imagine how hard and how messy that gets very quickly, right? No one kind of knows what the variables are anymore. So otherwise, it's almost always safer to declare the variables that you need in the function or the blocks, so you don't overwrite other variables and you don't use other variables by mistakes. And that's pretty much it for today. Are there any questions?